Hi, good morning. We're back for another math lesson. So I hope you have either your whiteboard or pencil and paper. We're going to do some review problems today. And of course, your math worksheet. We are on lesson 138, forgot the number, and that's pages 249 and 250. So this is a new concept, and it's going to take quite a bit of practice if it's not making sense to you the first time. Keep trying. I will be contacting everyone on Monday, so if you have any questions about this, then will be a great time to ask, and video chats are really good for that. So if you have trouble with this, I'm still here to help you, and just remember, this is something that once you got it, it will stick with you. You'll use it all the time in math and your higher grades going forward. And the more you practice with it, the more comfortable you get. But if you don't understand it right away, that's okay. We will keep working, and I know you can do this and can get this. Others of you, you'll pick it up right away, and that is fantastic. So we're going to start with, yay, one of these addition problems. We haven't done those in a while. So if you've got your whiteboard or paper, go ahead and do that. Pause while you solve. I have my answer covered. So let's see if you came up with the same thing. Go ahead and pause it while you work this problem. Okay. Even though it's just addition, it's good to warm up our brains and keep our math skills solid. You should have gotten 385,089, and you better have put that comma. It does belong. Don't forget those things. Okay. Are you ready for some mental math challenges again? We've got some long ones today. I've got 4 mental math problems. See if you can get all of these by following along. Again, you're not writing these down. You're just listening and solving. All right, the first one we have is 2 times 2 times 4 times 4 divided by 8 times 12 plus 4 divided by 25 times 50 plus 100 divided by 2 divided by 25 equals. Did you get 6? I hope so. Let me know if I go too fast. I can slow down a little, but by now, honestly, these should be things that you can keep up with mentally and keep pushing yourself and keep trying. Most of you have gotten really, really close, even if you've missed by a number or so, so keep working at it. 39 plus 7 plus 2 divided by 2 times 4 divided by 12 times 7 plus 4 plus 40 minus 7 minus 3 divided by 10 equals. Did you get 90? That's the answer. Third problem, 200 minus 50 divided by 3 plus 25 times 2 divided by 6 plus 3 times 10 plus 8 divided by 11 times 9 plus 100. You should be at 172 if you followed along carefully. Last one today. 9 times 9 minus 9 divided by 8 times 4 plus 4 divided by 8 times 10 plus 12 divided by 2 plus 4 divided by 7 times 9. You should be at 45. Okay, 45 is where you should be for that. So that was our quick warm-up and review. Now let's go ahead and look at your worksheet as we go through today's lesson. I'm going to use examples that are not in the yellow section, but it's still going to be the same steps. We're still going to read through it together, but then I'm going to show you a more streamlined way to write it that doesn't take up an entire worksheet, and also a place for you to save it. So you might want a piece of paper to do notes, to keep track of and study when you're going through and practicing as we're looking at the steps. All right. So lesson 138, solving equations. We're going to look at the facts, and then we're going to practice some of these steps. First of all, an equation is a mathematical sentence that uses the equal symbol to show two expressions are equal. We're used to seeing that equal sign. An equation is like a math sentence. You've got your subject, whatever is on this side, equals is your verb, it's your is. And then the other side is kind of like your predicate nominative. This is this. Remember we said it can equal the subject, right? That's what math equation is. It's a math sentence. Others can be expressions or phrases, but when you've got that equal sign in an answer, you've got a full equation, you've got a full math sentence. An algebraic equation contains an unknown number that's usually represented by a letter. We don't use O because it looks like a 0. We don't use a lowercase l unless we italicize it like in our length plus width formulas, or you do the cursive L, because that looks like a 1. We use a lot of X, a lot of Y. N is frequently used, but really you can use any letter. We just don't use O or L because that can look like a number. We call that actually a variable. Your book doesn't tell you that, but it's good to know that and keep that in mind. Anytime variable just means unknown. It could change from time to time. X is not always the same value in every problem. It varies, okay, whether it's N or T or whatever. You don't know it. Your book calls it the unknown, but get used to hearing the word variable. It's just a letter or a symbol that's standing for a value in an equation. Skip the example for a second. And fact 2, we need to remember that a number and a letter appearing side by side is showing multiplication. So when we're looking at these problems, where did I see it? Oh, for example, in this one, 4 and T, when they're stuck together, that's multiplying. Fact 3, we need to remember, just like with fractions, that fraction bar is the same as using division. So when we see that, that's a division problem. Okay. Now we're going to go through the little steps in the example problems, not programs, and notice up in number 1, we've got some steps that they have there. It says simplify the side without the unknown number, and you're going to write the new equation below. Then it says to find the value of n has to be alone. Okay. And whatever is done to one side, look in the bold print, it's also going to be done at the other. Now I've simplified these directions. This is what I've done when I've taught pre-algebra and Algebra 1 students to make sure the directions are a little more condensed than your giant page with a lot of words and numbers. Our goal is to get the variable, remember that's the name for the letter standing for a value. So our goal is to get the variable alone. Okay. It's like the Brussels sprouts that no one wants, leaves them alone on their plate, and then eats everything else. That's going to be alone. Okay. It's lonely, it's sad, it's pathetic, and that's what we want for once. All right, so our goal is to get that variable alone. How are we going to do that? Let's start by practicing this first step. 1, we're going to simplify the side of the equation with no variable. So we've got 4 times 3 in this case, no variable. We're going to ignore this part, and we're just going to look at this side. Think of the equal sign as like a volleyball net or a tennis net. It's clearly cutting that equation into 2 sides. So we're going to work on the side with no variable. And we are going to, yes, rewrite it. So 4 times 3, this is what I'm going to do first. That's a very easy 12. And then I write what's left of the equation. Same thing here, variable, no variable. Hey, this part's easy to do. I'm going to take care of this side first. So I still have y over 3 equals, but I can simplify that to 6. With me so far, we're still on step 1 of every single one of these problems. Then 18 over 2, I can do that, okay, because I know that's dividing. So I'm left with x minus 5 equals 9. Each time I rewrite these things, we're going to end up with these smaller and smaller equations. And trust me, you're going to get into ones that, are 15 numbers long. And if you do your work like this, just one part at a time, it will be a whole lot easier on you to get that right answer and solve it. This side has the variable, so we're going to take care of this side first. Simplify the side with no variable. So I still have 4t, but now I have that it equals 64. Okay. All right, now, the second step to any equation is to undo the operation with the variable. What does that mean? Well, whenever we have a variable with an operation like adding, dividing, subtracting, or multiplying, we want to make it like it never, ever happened, because we want to get back, it's like working backwards, to where that variable was totally alone. So to undo that operation, it's kind of like rewinding. It's going to look backwards. We're going backwards. The opposite. So if I'm adding 6 to n, to undo that, I need to do the opposite operation. Okay. Minus 6. What's the opposite here? Multiplying by 3. Okay, I'm doing the opposite operation so that I can undo this part, get rid of it, get it out of there. So the opposite of subtracting 5, if I'm going back to the beginning, I add. And then this one, I'm going to start using a fraction bar to show dividing in equations. It's a good habit rather than a box or the division symbol. Okay. It just keeps it consistent, and honestly, your 7th grade teacher is going to want you to use it this way. Okay. So we're not using the division box, we're not using the symbol with the 2 dots, we're going to start showing division this way. So by undoing the operation that's with the variable, essentially what it's doing is getting rid of that number. We can exit out, because the opposite of taking away 5, right? If you've stolen 5 of my cookies, how do you undo it? Well, you give me them back, all 5, or you get beaten. Just kidding. All right? Once we've done the opposite operation, we've gotten rid of that number. So, it is true, we now have that variable, that letter, alone on one side of the equal sign. There is no one else on its team. It is sad and lonely, and it's going to have to stay that way because that's what we want. Now there's one more rule, because we're not done. N does not equal 12. Look at the third rule. What you do to one side of the equal sign, you must, underlined and in all caps, do to the other. Think of it like a balance of scales. If you have one side heavier than the other, they're not going to be equal. And my equation is going to have to say that they're equal. So if I have a scale with 5 pounds on one side, what do I have to do to the other side to make it even? Add 5 pounds. Okay? Then they balance out. If I've taken away 2 pounds on one side, now it's lighter, I have to take 2 pounds away on the other side to make them equal again. The same works with numbers and equations. So if I'm getting rid of the 6 addition by subtracting over here to keep it equal, right, I have to subtract it here, because subtracting 6 can't be the same as nothing. Subtracting 6 is the same as subtracting 6 here. Okay. If I'm multiplying by 3 here, Well, the only thing that's going to make it equal is if I multiply by 3 on this side as well. That allows me to keep that equal sign because both sides of the equation are going to be balanced or the same. If I added 5 here to take it away, the only thing that's going to make it equal is if I do it to both sides. Same thing here, dividing by 4 is the same as dividing by 4 on this side. So I can change amounts on either side of the equation to keep them balanced, but it's got to be the same thing. And what's important in showing your steps like this, again, is to help you keep track when you get into more complex equations. Don't freak out if this isn't quite making sense to you yet. We're going to do several of your examples together and work through them, and you'll get the hang of it. I know you will. So now we can simplify this side, because if we're taking away 6, we're not left with 12 anymore. You found the value for 6. Now some of you might say, yeah, I figured that out. 4 times 3 is 12, and the only thing that would make sense is 6 times 6 equals 12. I can do that in my head. Great. But there are going to be a lot of equations where you can't. And this starts out small and simple as a good way of testing yourself. Did you get the right answer? But also building those habits. Some of you hate writing it out. You want to do it in your head. And I am telling you, number one, your future teachers are not going to accept that the same way I won't. And number two, you're only going to throw yourself into a lot harder time of getting it right if you don't build a good foundation of doing things the right way now. And then we can check it, because if n equals 6, we put it back in. Instead of the n, let's check. So if n is 6, I should be able to put it back into the equation. 6 plus 6, does that equal 4 times 3? Well, on this side it gets 12, on this side it gets 12. That is how you check yourself to make sure you found the correct value for that variable that I know. Going to this one, well, we got rid of that and got y by itself, but it's no longer 6, it's 18. That is the value for y. Let's check and see, does it make sense? Did we find the correct value? I should be able to go back to my original equation and put this number in place of y. So 18 over 3, does that equal 6? Okay, because we started out with y over 3 equals 6. What is 18 over 3? It is 6, and that is true. 6 does equal 6. Next one, we got rid of the 5 on this side. We kept it equal by adding the 5 on this part as well. So 9 plus 5 is 14. Because there's usually a lot of steps and work and crossing off and adding, subtracting, multiplying, or dividing when you're solving equations, it's very, very helpful to me and future teachers. I'm keeping you getting prepared. All right, to circle your answers so we can very clearly see what you're saying the value is. And again, we're going to check by substituting this back into our original equation. I'll erase that line if it looks confusing. And double check our work. So I should be able to say 14 minus 5 equals 18 over 2. 14 minus 5 is 9. 18 divided by 2 is 9. It checked out. This is the right value. Here we got rid of the 4, multiplication by doing the opposite and dividing. We kept it balanced by dividing on both sides. So we have t by itself But now instead of 64, we have 16 is our value for t. Let's check again. I should be able to substitute this in. Now remember, when we are putting it in, we cannot put 4 and 16 together like we would a 4 and a t. Okay. That's not going to work because it will look, sorry, I'm going to put my 4 back in here. In black. It's not going to work because it looks like 416. So you can either use the dot to remind yourself that this was multiplication, or get used to seeing parentheses showing multiplication as well. So set it up as a multiplication problem. Do not put two numbers together. That's not going to be multiplying. A number and a letter, yes. A number with a number, you need that dot. Don't use the X because we've got letters in here. And we've got parentheses. Both of those can be used to show multiplication. All right, so 4 times 16. If you do that out, you get 64. Well, 64 certainly does equal 64. We've got the correct answer. That might seem overwhelming and a little confusing. So let's do all of section 1 together. Now, if you feel you are ready and you've got it, go ahead and pause it here. Do your section 1 problems and then come back and check and see, did you show your steps and your answers correctly? The rest of us, we're going to go ahead and work through them together to make sure that we're showing our steps right and to get some extra practice in understanding the concepts. Okay. All right, so section 1, we've got 4 equations. We're going to start with A, which gives us x plus 3 equals, there's our dividing sign separating the two sides, and then 27 over 9. Remember, our goal is to get that variable alone. How do we do that? One step at a time. Simplify the side of the equation with no variable. Get the easy part out of the way. That part shouldn't be confusing. This has a variable. I'm going to ignore that for now. I'm going to take care of this side. So when I rewrite it, I still have everything the same over here, x plus 3. But now on this side, I have 3. So I've got a little bit of a smaller, simplified equation. Now step 2, undo that operation with the variable. Get rid of it like it never happened. I'm going to take away that 3 because the opposite of adding, to undo it, would be to subtract it so that it's gone. Bye-bye. My variable is alone. Okay. Thing is, now it's not going to be a balanced equation. So if I subtract 3 here, I've got to do the same thing on this side. Remember to keep it equal. So I also subtract 3 here. Now the scale's balanced. The equation is still the same because we've done the same to both sides to keep it equal. 3 minus 3, now we have a 0. Here's our value. Let's check to make sure. And I'm going to check here instead of next to it so I can leave some space. Let's put this in place of the x back in our original equation. 0 plus 3, because x equals 0. 0 plus 3 equals 27 over 9. Is that true? We know 0 plus 3 is 3. 27 divided by 9 is 3. So it checks out. We did the right answer. And it's always good to show out checking your work. This is to help you, not to make you just have to write random more stuff. okay? It's not to punish you. It's not to be an annoyance. It's important because you want to be able to do it well and to do it right. It's like a puzzle, figuring out the correct answer and going back and looking that you did it correctly. Problem B has it set up this way. N over 5 equals 7 plus 4. Get the variable alone. Start by simplifying the side with no variable. This should be starting to look a little more familiar, make a little more sense, come a little more easily, be a little more quick. Okay. Now we undo the operation with the variable. Well, this, if you remember, is dividing. So the only thing that's going to make sense here is multiplying. And the reason why I put it up like that is because we've got a fraction. Okay, so when we are dividing by 5 and then multiplying by 5, we do the opposite, and we know those would cancel out, but you don't have to write it as a fraction. That's just, if you were wondering why I'm putting it up here, that's why. Okay. So I undo it, I get rid of it. Problem is, to keep it equal, I've also got to multiply by 5 on this side. Now n is alone, great, but I don't have 11 anymore. Now on this side I have 55. Let's check. By, instead of n, in this equation, let's substitute our value in. So n, which is 55, divided by 5, equals 7 plus 4. 55 divided by 5 is 11. 7 plus 4 is 11. They are equal. It checks out. We did it correctly. C. The problem we have is 3y equals 15. Is that a minus sign? No, it is plus sign. I'm glad I looked. Plus 6. Goal, get the variable alone. You're going to get tired of hearing it. I don't care. I want it to stick in your head. Your goal is to get the variable alone. Simplify the side of the equation with no variable. We're going to keep that 3y for now. On this side we have now what? 21. What's step 2? We are undoing the operation that's with the variable. Remember, the variable's the letter. How do we undo this? This is showing what operation? Multiplying. So we undo multiplying by dividing. And remember, I told you, get used to using that fraction bar as a way of dividing. Plus, it'll keep things more streamlined and neat on your work. And it's gone. Y is by itself. But to keep it equal, I also have to, step 3. What I do to one side, I must do to the other. I have to also divide by 3. Dividing by 3 equals dividing by 3. It keeps it balanced. 21 divided by 3 leaves me with 7. So I have y by itself here, its number value there, and let's check our work. Going back to the original and putting this in place of y. So 3 times y becomes 3 times 7 equals 15 plus 6. Well, we know 3 times 7 is 21. 15 plus 6 is 21. They are equal. It does check out. Last one we're going to do together, and then I want you to do section 2 on your own. And then we'll go over the answer. And if you didn't do it correctly, you can go back and fix it on your paper. So last one, let's do n minus 8 equals 4 times 3. I'm going to go a little more quickly because this should be a little more familiar now. Our step is to get the variable alone. All right, that's our goal. So how do we do that? Step 1, simplify this side. 4 times 3 I know is 12. I still have my n minus 8 over here on this side of the equal sign to deal with. Step 2, I get rid of this. This guy's got to be alone. How do I undo subtraction? I add it back in. Gone, like it never happened. How do I keep both sides equal? I add 8 over here as well. Adding 8 gets rid of it here. But on this side, our 12 is now 20. Let's check it. We need to substitute this if n is worth that value. 20 minus 8 equals 4 times 3. 20 minus 8 is 12. 4 times 3 is 12. We did solve it accurately. It checks out. We've got a complete answer. We're going to do A and B, checking them together right now. You're going to do it on your own. I'm not going to do the steps out on the board, so go ahead and pause while you do those 2 problems, and that way when I give you the answers, you've got them correct, you know you've got the topic down, and you can go ahead and complete the rest of the page. There's no problems that we're not going to complete today, so if you've got this solid, you understand it, quickly do A and B, listen for the answers, and then move on and finish the rest of the worksheet. We will be practicing this more again in the next lesson, so don't freak out that this is the only time you're going to see it. But if you follow the steps carefully and show your work, it'll make it much easier and simpler in the long run. So quickly do number 2, A and B. Pause that, and then we're going to go over the answers. All right, hopefully you worked them both and showed your steps like I've trained you. Even though I can't see what you're doing, I'm still very concerned that you're doing it the right way, and I want you to do your best, and I want to be able to do the best that you possibly can. A, the answer is x equals 18. You had to divide first to get x minus 4 equals 14. To undo the operation, you had to add 4 to both sides, and you should have gotten x equals 18. When you check it out, 18 minus 4, 14. 28 minus 2 is 14, so they are equal. B, you should have gotten x equals 5. Your first thing that you had to do wasn't even this, because there was nothing to solve on that side. They just gave you a 10, so they made it really easy. So the only things you had to do for number 2B, what is B? This one's sign language, so 2B, you only had to get rid of that number that was with the variable. You undo that multiplying by 2 by dividing both sides. So divide by 2 on the one side, you get x. Divide 10 by 2 on the other side, you get 5, and you can check it out. 2 times 5 does make 10. So finish C through H. Then you're going to do your story problems, one where you're finding the answer to the length of the side, but they gave you the perimeter. So you've already got the big answer, what it was all the way around, what was the length of that side of the square. And of course, in a square, all sides are the same. And then B, the area of a rectangle is 40 square feet. They give you the length. Find that width. Remember always to use your measurements in your answers when you have problems with measures. I need to know what unit. And then number 4, find the perimeter or circumference. Circle the next part. It says write the formula without that multiplication symbol. Go back to what we did yesterday or the last lesson and look, how did we write those formulas without that x as the multiplication symbol? Then solve. And number 5, you're just finding the answers. So I hope that was helpful. If you do have questions, I'll be contacting everybody on Monday, and we can work through some more examples if you need to, explain it in another way if you need to, and of course we will be working on it more in some future lessons. So this is not the only time we'll practice it or see it, even though we're in virtual school. All right, so I hope you're having a good day. Go ahead and get to work on that math sheet, and I'll see you the next math lesson. Bye.